On the 7th June, there was a video I have uploaded to YouTube, and I heard that the first 6.5 minutes, the sound was kind of bare minimum, and it was quite difficult to listen to. So I thought of creating this video to fill that gap, right? So that first video, that first part of that June 7 video, I was focusing on the method of how electrons are filled in atomic shells. You know the periodic table, they got different atomic numbers for different elements. So there is a method of filling those electrons in. So if you take a glass and you go to the tap to fill that water, the water will be filled from the bottom of the glass first, and then it will be, once it is filled, it will pour over. So that's the analogy I'm going to use here, right? But in this case, I'm going to add the golden rule that I learned when I was a schoolgirl, right? When learning chemistry. It's the same golden rule. It worked for me. So I'm 100% certain it will work for you. So what we are going to look at here is, let's consider N, you know, the N is an unknown figure, N as energy level in atomic orbital or shells, right? Energy levels can vary from 1, 2, 3, 4, 5. So if N is 1, meaning it's the first energy level, so it will only have 2 electrons. Then the next one, if N is 2, it's called the second energy level, will only have 8 electrons. If N equals 3, another 8. See, it's third energy level and it will have only 8 electrons. But if N is 4, there's a quite large energy level which will have up to 18 electrons. So you need to remember that the first one is the one closest to the nucleus. Okay, the bigger ones are always away from the nucleus. So this is, you know, if you draw the circles and put the electrons, we call it Bohr diagrams. B-O-H-R, Neil Bohr is the one who introduced that. But you don't need Bohr diagrams because the chemistry is always relying on the electrons in the outer shell, because that's where the elements are going to make bonds by different methods, right? Because all the elements wanted to reach a stabilized state like in noble gases or inert gases. But as they do not have fully filled electrons in its outer shell, they are looking at possibilities whether to give electrons or get electrons to reach that stabilized level. So what we do is, this is the Bohr arrangement. I did not draw circles. It's not required that much. So what we are going to do is, let's write the Bohr's electron spread in short. So to write in short, you first write the first shell. So it's 2, and then you put a comma or a forward slash. Then you write down the electrons in the next shell. It's all based on atomic number. So if the second shell is having 8 electrons, then you can put it 8, and then put a comma or a forward slash. And the electrons in the third shell we write next, right? In this case, 8. And then put a comma or a forward slash to write electrons in the fourth shell, which is 18 electrons. Let's consider one example so you will understand that. Calcium, which got 20 electrons, the atomic number is 20. So let's see how the electrons are spread among these shells. Of course, when follow the golden rule, the shell closest to the nucleus will have 2 electrons, right? You write 2, then you put a comma or a forward slash. The next shell will have 8. Now 8 plus 2, already 10 electrons gone. So from calcium 20, what is left is another 10. That 10 can be spreaded with the third shell having 8 electrons. And then what is left is only 2 electrons in its outer shell, the fourth shell. So if you look at that, I put the outer shell electrons little away from that because I'm going to circle that now. So that is very important here. This outer shell, we call it valence shell, right? That valence word is really important because the whole chemistry is based on that valence. It's called valence shell, valence shell. But from valence word, we get another word called valency. The valency is the glue of forming bonds. So when you know, the next lesson is forming bonds, and then reactions, you know, precipitates, and it goes on. So the whole chemistry is relying on this valency of elements. It's so important. I'm going to get this arrow, and then what we are going to do is we are looking at the electrons in the outer shell to draw Lewis dot diagrams, right? So outer or valence shell. So in the case of calcium, you need to write calcium first at the center, and then you need to put number of electrons in its outer shell. Of course, here it is 2 dots, 1 dot, another dot. As I said earlier, all of these elements except those those are in the inert gas or the group 8, the rest is all not stabilized. So to stabilize, in the case of calcium, it got 2 electrons in its outer shell, so it can give these 2 electrons to another element, or it can get 6 from another element. So remember, giving electron is giving out a lot of energy, right? So therefore, in terms of calculating, you know, in terms of energy lost or gain, it's easier to give 2 electrons and lose that energy rather than getting 6, because calcium do not have energy to get, right? So that's, we are talking in terms of energy. So let's see how calcium is going to give these electrons. 1 electron it's going to give out. Remember, calcium with these outer 2 electrons, it's in the neutral state, meaning electrons and protons are equal, right? When giving 1 electron out, meaning 1 negative charge going out, that can create 1 positive charge. If the other electron, that's the electron giving out, the next electron is also going to give out. So calcium will end up having 2 positive charges, plus plus, but we don't write plus plus, we write it as plus 2, right? So that's how calcium plus 2 ion is formed. What I want you to do is take a step backward and look at all the elements in group 2, see whether they are doing the same thing, right? Now look at the number 2, the outer shell electrons that I have circled. Here I'm getting a blue arrow. Look at the kind of ion it formed, plus 2 ion. Okay, this is a character of group 2 elements, right? So similarly, you need to look at group 1, group 3. So you need to compare. There is a pattern. So group 1 elements will all end up with plus 1 ions. Group 3 elements will all end up with plus 3 ions. So that's interesting. I hope this is crystal clear. So now what you need to do is you continue with my original video on the 7th June from 6:30th minute onwards. So the information is crystal clear. Make sure you grasp all of this information, because getting through in the examination is the most important. Okay, I hope you will make the maximum, you will get the maximum benefit of these resources. Good luck, everybody.